Okay. Jagan, excuse me, Jagan.
Yes.
Can you be on hold? Like the student has called back.
Yeah, yeah.
Can you tell him to join?
I'll be waiting for 2 more minutes. Please ask him to join.
Okay. Okay. Yeah.
Yeah.
Fine. Thank you. Yeah. 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 I have sent you. Okay. Fine. Did you check with the link? Okay. Okay. Yeah. Okay. Okay. Fine. Just make it. Okay. Okay. Thank you. Hello. Jagan, are you there?
Yes, Bindu, your person is joining?
Yeah. He's going to join in 2 minutes.
Yeah, yeah. I'll be waiting. Okay.
Okay. Fine. Thank you.
Hi, Sandeep. Sandeep, can you hear me? Hello? Sandeep, can you hear me? Famous websites. These are the famous websites, right? So, nowadays, each and every person is having Gmail ID. Almost, almost 90% of the people is having Gmails and Google Plus accounts as well as Facebook accounts. Facebook accounts almost all, apart from farmers and uneducated persons, the complete remaining people is having Facebook accounts in these days. The same way, LinkedIn, Twitter, YouTube, No, Sandeep, it's not for data mining. It's not for data mining. This is for analytics. This is for big data analysis. Okay. See, all these companies are having n number of users. The earlier, see, I'll take one example from this video, from this slide, YouTube. Just this is an example, video popularity growth. See, in the last 3 months, a video got popular 31% within last 3 months. You can imagine how it may get popular in next 3 months, next 6 months, next 1 year. For example, there is a video called Gangnam Style video available in the YouTube. I think everyone knows how much popular video it is. Okay, so in the same fashion, there is so many videos are available in the YouTube. Okay, for example, if you are watching a Gangnam Style video on YouTube and you like that video and you share that video with your friend, so that means there was some data generation. There was some data generation. Data format can be anything. You are sharing the information with your friend. So there is a data generation, right? So like you, many people, many users will be sharing the information, uploading the videos, sharing the information, commenting on the videos, writing your comments on videos. You can do so many things on YouTube. By these comments, videos, updates, sharings, every month, the data will be generating. So the data will be in not GBs, not TBs. This is in petabytes. Petabytes. We'll see data level by level in detail in the next coming slides. In detail, we'll see that. So this is the way huge amount of data is generating. Not only this, social media websites, it can be banks, it can be telecom, it can be, eBay, kind of e-commerce websites also comes under this. So, and all the businesses are generating, all the business are generating huge amount of data in these days. If you have any doubts, please ask me. Otherwise, I'll go ahead and continue with the next slide. Okay. Fine. Okay. Thank you. Next. Why do we need Hadoop? The same question. I'll be giving you another example. Data is growing like anything. Data is growing like anything. It's growing, and if you see in the 2004 and 2005 Facebook example, there was very less number of users. Which one is popular at that point of time? 2004 to 2006. There was a famous social website, got very famous in 2004, 2005, 2006 area. What is that? That website name called Orkut. Right? So, that time, Facebook doesn't have much users. Many people don't know about the Facebook. Now, from the 2006 onwards, if you can observe the curve, data growth curve increasing like anything. Increasing like anything. Now, till 2010, I have this map till 2010 only. Then 2010 to 2012, 13. How much growth will be there in the Facebook users? You can imagine. You can imagine. So, in the 2007, 2008, the Facebook users increasing was started. Then, till 2012, 2013, each and every user, apart from uneducated people and farmers, okay, apart from uneducated people and uneducated farmers. Apart from these two categories, everyone is having a Facebook account. From the small kid to from the 90 years of old man is also having Facebook account. That much popularity is. So, for example, if you are having a Facebook account, what you will do? You will share your daily activities with your friends on Facebook, and you will upload your photos, videos in a Facebook, and you will share across with your friends. They like us, they like your photos, they like your videos, they'll comment on your videos, and they also have a facility. They can also share your photos and videos with their friends. Okay, so by this activity, a huge amount of data is generating. For example, if you are uploading a photo, how much MB it would be? It would be around 10 MB or 5 MB. Yes, it would be 10 MB or 5. Then, if you are uploading this on Facebook and your friends are going to comment on that, so the data is getting increased, and you are uploading a video, how much MB it would be? It would be 50 MB to 100 MB, it can be anything. So again, that is a data. And your friends are commenting. Again, that is a data. So here, how many types of data we have? We have a video, we have an image, we have a text. This kind of data is not able to stored in existing traditional databases. That is the reason we need a new framework called Hadoop. Okay? If you are okay with this, I'll go and continue with next slide. Fine. Now, if you can see the slide, one moment. Now, if you can see this slide, the data started with bits, bytes, kilobytes, megabytes, and gigabytes, and terabytes. Right? Bits, very small amount of data. Bytes, still very small amount of data. Kilobytes, KBs, still very small amount of data. Megabytes, still it is a very small amount of data. Gigabytes, yes, it's a small data or big data. Yes, it is a small data. We can process these data with the existing traditional systems. Existing traditional systems are nothing but Oracle, SQL Server, Sybase, Teradata, Netezza. These kind of databases, softwares called traditional softwares, traditional databases. Now we are talking about petabytes and zettabytes. We were just before talked about how the data, petabytes of data generating. So are we able to process these petabytes of data, zettabytes of data, unstructured data in any of the existing traditional databases? That is the question. That is the question for everyone. So that is not at all possible. Anyone is asking any question? If you have any questions, you can ask me. Fine. Now, these petabytes and zettabytes of data is not able to process by existing traditional softwares, databases, or systems. That is the reason Hadoop came into the picture. How Hadoop is going to handle petabytes of data, zettabytes of data, or XYZ data. We will see in the next classes. If you have any questions, you can ask me. Otherwise, I'll be going for next slide.
Oh, I have a question here.
Yes.
So, so we have two types of data basically. One is structured and the other one is unstructured data, right?
Yes.
So can Hadoop also handle structured data?
Yes. Hadoop can handle everything. Structured data, unstructured data, everything.
Okay.
Okay. Now, if you can see this slide, need to process petabytes of data every day. Approximately, just before we talked about various companies, how they are generating data day-to-day transactions. We will see here, we can see here, Facebook is generating 300 petabytes of data every month on an average. And Google is generating 400 petabytes of data in a month on an average. The same way, eBay 250 petabytes, Twitter 100 petabytes, Picasso 150 petabytes. I think you all are familiar with these companies, right? Fine. So these all are generating huge amount of data every month, every day. Okay. Facebook, 300 divided by 30, 10 petabytes every day. So Google, 400 divided by 30, something. So these kind of data generated by all these companies. So existing systems are not supporting for big data. That is the reason Hadoop came into the picture. Okay. Now you can see the performance of traditional existing systems are not sufficient and supportable. The existing traditional softwares, databases, systems are not sufficient and supportable. We are unable to process petabytes of data with current traditional systems. That is what just before we discussed. We are unable to process unstructured data with current traditional softwares, databases. You can see how we have to process how we have to process a structured data into a traditional database. You might be knowing about traditional database. As you can take any example, SQL Server or Oracle or Teradata or Netezza, whatever the database it may be. You can see you have to define a schema, you have to first design database, then after that define a schema, then after that you have to create a table, then after that as per the table structure you have to insert the data. You have to write a query, a SQL query, and you have to insert the data. Then only the data will be inserted into the table. Otherwise, if you can see in the slide, there was one EMP table example. Are you able to see that? Are you able to see this EMP table in a slide?
Yes.
Okay. So, if you can see, EMP number is defined as integer and primary key for the purpose of uniqueness. Okay. I am trying to insert a non-numeric value into this column. Is it going to accept? Is it going to accept? No, it will not be accepting. It will throw you an error. Integer is, primary key is not going to accept a non-numeric value. Okay, so only we can process structured data with an existing available softwares, existing traditional available softwares or databases. So I'll take an example here, and the unstructured data. Unstructured data. All you guys are having Aadhaar cards. How the Aadhaar card is getting processed? What are the basic criteria which we need to follow to get an Aadhaar card in India? You may are from US or somewhere. In India, there is the Aadhaar card concept where we need to follow to get an Aadhaar card. We need to follow some basic criteria. That is, we have to fill application form. They'll take our biometrics and fingerprints, right? All these information will be saved in a place. All form information and biometrics and fingerprints, image, everything will be saved in a place. Okay. So, are we able to process this kind of data with an existing available traditional systems or not? That is the question. So, no, it is not at all possible with existing traditional databases. That is the reason we are looking for other alternative. Is nothing but Hadoop. So, in the future, forget about now. Yes, now still we are able to handle in some cases. Forget about now. In the future, how it is going to be? The failure is expected. The failure is 100%, not 100%, 1000% expected. That is the reason everyone is talking about Hadoop. Everyone is looking at Hadoop. Any questions here? Fine. See, the number of machines in a cluster is not constant. Okay, the number of machines in a cluster is not constant. I'll tell you what is cluster in the next slides. Before that, we will, in general, I'll tell you. In a Hadoop, if you have 100 GB of database, 100 GB of database. Now, you are getting from your business another 100 GB of database. So you don't have space to store that another new 100 GB of data into your existing Hadoop cluster. What you will do? You are going to stop your business? No. You are going to, put some data into somewhere? No, it is not like that. So what you will do then? We will add one more node to the existing cluster, and node is nothing but a machine, a computer. A machine, a computer. One more machine to the existing cluster, and you will be using it as another database. So you will be saving your data into the new machine, and it will be connected to the existing cluster and all together working at a time. Okay? And next, in the existing traditional systems, we cannot, in the existing traditional databases or software or systems, we cannot expand those database size, or we cannot add a new hard drive or hard disk to the existing machine as the data is increasing day by day. Yes, you can ask, yes sir, no. We can increase by adding one more hard disk to the existing database. Yes, you can add one more new hard disk to your laptop or computer or whatever. How many hard disks you will add? Yes, you are adding 100 GB hard disk. Yes, you have added 100 plus 100, 200. Now for the time being it is okay. As the data is increasing like anything, day after tomorrow, one more 100 GB data is coming. So what you will do that time? So there is a failure expected. That is the reason everyone is looking at Hadoop. Okay, that is the reason failure is. That is the reason. That is because of this failure, everyone is looking at Hadoop. Okay. Okay.
So this is the hardware side of Hadoop. When you talk about storage and increasing the space size
It
with
is.
nodes.
It is. Yes. It is. It is not like hardware. It is a kind of framework. We can add. See, it is. I'll tell you example. If you can, you may have a mobile phone, right?
Yeah.
So there will be some limitations and for each and every mobile. You can add 8 GB memory card to your mobile, but not more than that, right?
Yeah.
But not more than that. So in the same way, you can add some database, hard disk, or any other thing to your existing system, but not, it is not unlimited. That is what I want to tell you. It is not unlimited.
Yeah.
Completely there is a failure expected. But in Hadoop case, it is not like that. Here, you can add n number of nodes to the existing cluster. How much data you are getting from your business, that much data can be saved in your Hadoop. Okay?
Okay.
Fine. Now, the core, as I discussed just before, the core Hadoop Apache consists of two modules. One is HDFS, Hadoop Distributed File System for storage, and MapReduce for processing. MapReduce consists of two modules again, Mapper and Reducer. We'll discuss in detail about this in the next slides. This is a HDFS architecture. This is a HDFS architecture. If you can see in this, name node is the master machine and data node is the slave machine. Name node is the master machine and data node is the slave machine. We have here 4 data nodes and 1 name node. Name node will be assigning task to the data node. Data node will be saving the information and processing the information and responding to the name node. Name node will be collecting all the information from data nodes and it will be giving output to the user. So here we have one. I'll take an example and I'll explain you. This is a database. You have 300 GB data you have. Now you are loading these data into your Hadoop. So how it get processed? Is this complete? This is the master machine. This is the master machine and this is the slave machines. This is the slave machines. Now all these slave machines connected to your Hadoop master machine. Now this is the slave. Again, this is the slave. This is a slave. Okay. you have 300 GB of data file with you. Now you are processing this data into Hadoop. You are loading this data into Hadoop. How it will be saved? How it will be saved? Is this completely 300 GB of data? Go and save it to this? No. And this also same way? No. And this also? No. How it will be processed? It will be processed. There is a separate mechanism. Internally, Hadoop will be taking care of this. The first 100 GB of data will be stored on first slave machine. First 100 GB of data will be saved here. Second 100 GB of data will be saved here. And third 100 GB of data will be saved here. In the same way, it is replicating the data again. In the same way, it is replicating the data again. Replication. What do you mean by replication? The data will be saved in other nodes as well. The data will be saved on other nodes as well. See, we may have another set of nodes. These nodes are also connected to the same machine, master machine. Now, this data is going to be replicated. How many times you want to replicate? That many times you can replicate. How many times you want to replicate? That many times you can replicate. Now, the same data is also available here. This is the first 100 GB. I'll name it. 1 second. First 100 GB. Then second 100 GB. Then third 100 GB. Right? The first 100 GB is also replicating here. This is also again slave. Again, this is also slave. This is also again slave. Still here also can observe this. Here also data is replicating. Here also data is replicating. Now first 100 GB data is replicated here. First 100 GB. Then next here second 100 GB. Try to understand the concept. Third 100 GB. See, why we are replicating the data? We can ask a question. Why we are replicating the data? Answer for that is, see, now we processed everything, and we have loaded complete data into the Hadoop. Now, from there, data was loaded into this, and this. Completely the data was loaded. In the same way, data was loaded into this also, right? Now, you can see the same set of first 100 GB is available in, I'll make, 1 second, I'll differentiate. First, second, third, fourth, fifth, and sixth. Now, the first 100 GB is available on fourth node as well. The second 100 GB is available on fifth node as well. The third 100 GB is available on sixth node as well. For example, there might be a data loss, network issues, virus attacks, n number of issues can occur. N number of issues can occur. So, for example, because of the any reason, these database got crashed out. This node is not responding. The reason can be anything. This database is not responding now. Okay. Now what we have to do? Or we are going to stop our process, or we are going to stop our analysis? No.
No.
This database got stuck or crashed out, or it is not responding, or anything can happen to this database, 100 GB of data. So we will not stop our process. The Hadoop internally, it is distributed and stored in a various replications, various places. So as it is replicated in other area, automatically where it will look for where it is available. It is available in fourth node. It is available in this node. So it is automatically, it takes the data from this fourth node. It will automatically takes the data from this node and it will process. So it will not wait for anything. Automatically there is a mechanism in it. It will take the data and it will process the data. Okay. So for example, this is the case happening in existing traditional systems. Are we able to process our analysis? If complete data, this complete 300 GB data, this complete 300 GB data is in a traditional database. For example, Oracle. We'll take an example called Oracle or SQL Server 2008 or Teradata or Netezza. So it can be anything. So in this case, if my database got crashed out or virus attacks or not responding, so am I able to process my analysis? Simply no. I cannot process my analysis. I have to stop my work and I have to repair it, whether it may get repaired or not. So that is the reason Hadoop came into the picture. Everyone is looking at Hadoop. This failure is expected. That is the reason, Hadoop came into the picture. For example, if Facebook is, using this kind of traditional database, at this moment, okay, so whatever, because of the reason, whatever it may be, the Facebook database is not responding, or the users are going to be, wait till the Facebook rectifies. No, they won't be waiting for this. They'll be simply looking for other alternatives. That is the reason everyone is looking at Hadoop. Okay? Any doubts here?
Yeah. So
Yes.
does it mean for the traditional databases we do not have the concept of redundancy?
Sorry?
See, for traditional databases, so we don't have replication of data. Is that what you mean?
Yes. Traditional databases won't have any replications.
I mean, I'm a bit confused here because we have storage technology, right? Like
Yes.
SAN.
Yes.
So where we have like EMC and IBM, big companies providing storage.
Yes.
So I mean, we do replicate data over there, right?
Yes. See, for example, you can replicate the data.
Okay.
You can replicate the data. See, this a node is nothing but a separate machine. A node is nothing but a separate machine. You can replicate the data if your main machine is not responding. If your main machine is not responding, how you process your data?
Oh, okay, yeah.
If your main machine itself it is not responding, how you process the data? You cannot process. Okay?
Okay.
Yeah. Now, if you can see here, the red color is one set of data. The red color box is one set of data in the data node. The red color box is one set of data in the data node. Now, red color replicated 4 times. Right? Red color replicated 4 times. And green color replicated 4 times. And blue color replicated 4 times. We can replicate n number of times based on our requirement. We can replicate 100 number of times also based on our requirement. Okay? If the name node fails, name node is nothing but master machine here. If the name node fails, backup node will be available in the Hadoop and it will be taking care of all these name node activities. Okay? The name node fails, backup node will be coming into the picture and it will be taking all the responsibilities of name node and process will be continued. Process never stop because of any failure. Okay? What is MapReduce? This is the just before we discussed about HDFS. And now what is MapReduce? The core Hadoop consists of HDFS and MapReduce. MapReduce plays a key role in Hadoop framework. MapReduce is a programming model for writing applications rapidly that rapidly process large amount of data. See, we are able to load the data into HDFS. How we will load, how we will save, how we will process. We have seen that. The thing is to retrieve that data, to load the data into the Hadoop HDFS. To read the data from the HDFS, we need MapReduce. MapReduce consists of 2 modules again, mapper and reducer. Mapper is a function that processes input data, generate intermediate output data. As discussed, mapper is going to process the input data and generates intermediate output data. It's nothing but it will take the input from other data sets and it generates output data. In the same way, reducer merges all the intermediate data from the mappers. All mappers generates final output data and user will be access that data. It's nothing but mapper and reducer. We'll see when we are looking at in detail mapper and reducer architecture, we can see it in detail. Next, Hadoop cluster. Just before we were talking about Hadoop cluster, right? What is Hadoop cluster? A Hadoop cluster consists of multiple machines which can be classified into 3 types. One is name node and another one is secondary name node and data node. Name node will be having complete information about the data node. Name node will be having complete information about the data node. Which data loaded where in HDFS is nothing but data node. So which data stored which location. Complete information will be available in name node. And secondary name node, when the failure happen at name node level, secondary name node will be coming into the picture and it will be taken care by all activities of the name node. So complete activities will be taken care at the time of failure of name node. Okay. Now Hadoop process. Yes, we talked about Hadoop cluster and how Hadoop process the data. We'll see that. How Hadoop processing. Below are the services which runs on Hadoop cluster. Name node, job tracker, data node, task tracker. Name node, job tracker, data node, task tracker. Name node runs on a master machine, job tracker runs on a master machine. Name node will be having complete information about the data node. Job tracker, whenever the request is hitting the name node, the your job tracker will be assigning tasks to the task tracker. Task tracker will be available at slave machines, and according to the job tracker assignment, task tracker will be responding, and whatever the task is assigned by the job tracker, task tracker will be following that in the data node. So this data node and task tracker will be available at slave machines, and name node and job tracker is available at master machines. Okay. See, this is the Hadoop cluster architecture. Just before we were talking about job tracker and task tracker, name node and data node, right? See, you can see here master node is nothing but combination of name node and secondary name node. When master node name node fails, the secondary name node will be taking care of all the activities of name node. And slave node is nothing but data node. In the master node we have job tracker. Job tracker will be assigning, loading the data or retrieving the data, whatever it may be. So slave node will consist of task tracker. Task tracker will take the task from the job tracker and it will process the data. Whatever the task assigned by the job tracker, it will be executed by the task tracker. Okay. Next. Hadoop is simple, reliable, and scalable. Hadoop allows users to quickly write efficient parallel code. How many users maybe they can write n number of codes and they can process the data, and reliable. Hadoop runs on a commodity hardware. What is commodity hardware here? It can be a computer, it can be a laptop, it can be anything. It can be anything. So Hadoop runs on any machine, any laptop, any desktop. So there might be frequent hardware problems. So Hadoop can automatically handle such kind of problems. As we discussed, one laptop or desktop is not responding, so automatically Hadoop will be taking care of that and it will process the data from other available sources. Scalable. So we can increase or decrease number of nodes. A node is nothing but a machine in a cluster. A node is nothing but a machine in a cluster. So as we require 1,000 machines, we can also add 1,000 machines to the existing cluster and we can use it. Okay? Now, prerequisites for Hadoop. What we need? What are the things we need to install Hadoop on our desktop or laptop? Operating system we need. To install any of the software we need operating system. But to install Hadoop we need Linux based operating system. Can be Mac OS, Red Hat, CentOS, and Ubuntu. In our case, in our regular classes, we'll be installing Hadoop on Ubuntu. Okay, we need Java 1.6 or higher version is required to install Hadoop. Before installing Hadoop on our Ubuntu, we need to install Java 1.6 or higher version, and we require this space. We require this space to hold HDFS data, and RAM is recommended 2 GB. 2 GB or more than 2 GB is recommended, and this space, the same I've written 2 times by mistakenly, and a cluster of computers. Even we can install Hadoop on a single machine. We can install Hadoop on single machine. We can also install Hadoop on multiple machines. We can connect all together as a cluster, and we can use it. And next, Hadoop certifications. What are the certifications we have for Hadoop? Okay, so Hadoop certifications, 2 companies are providing. One is Cloudera and another one is Hortonworks. So you can write your certifications by Cloudera or Hortonworks. So I've named some of the certifications by Cloudera here. Cloudera Certified Developer and Cloudera Certified Administrator and Cloudera Certified Specialist. So these are the 3 various certifications available in the Cloudera. Now we will see what are the different costs of certifications. This is the certification cost for Cloudera Hadoop Administrator, and $295 for this, and Cloudera Developer $295, and Cloudera Certified Specialist is $145. So you can go ahead and write your certification after completion of this course. If you are unable to complete your certification, please come back to me. I'll help you to complete your certification. 100% that you are able to complete your certification by end of this course. Any other questions?
Yeah, I have a couple of questions here.
Yes.
So, I heard that in order to start learning Hadoop, I need to have knowledge of Java and Linux. So do I have to start learning Java?
Not
in
required.
order to understand this or learn this?
Not required. Java is not mandatory to learn Hadoop.
Okay.
Java is not mandatory to learn Hadoop. If you have Java, well and good. If you don't have Java knowledge, but still we can learn Hadoop. Hadoop not only who built for Java developers or Java programmers. Hadoop is open source, open for everyone. It can be a database developer, it can be database administrator, it can be Java developer, it can be anything. Hadoop is open for everyone.
See, for in SQL we write SQL queries, right, to process the data.
Yes.
So in Hadoop, what do we use? Is there like a language,
See, that is what I am telling. See, Java programmers will be using a component. SQL developers are using a component, and C programmers will be using another component. So for each and every person, Hadoop is flexible.
Oh, okay. Yeah.
So there is no concept called only one person have to learn Hadoop, and this person, no, you cannot learn Hadoop. It is not like that. Everyone can learn Hadoop.
Okay.
Any other questions?
Can I ask you one last question?
Yes.
So, see, what is the impact of big data on traditional, data warehousing softwares?
There is no impact on the traditional databases. There is no impact, nothing on traditional databases. This is separate and that is separate. Both the concepts are totally different.
Okay. No, I mean, what in terms of jobs perspective?
For example, in terms of jobs,
Yeah.
see, if you can, I'll tell you some keywords. You can search it in Google. What is the growth expected for Hadoop in the near future? How many jobs are created by this Hadoop in the near future? It's already near future in the sense 6 months back, 1 year back. Now it's already existing. What is the job opportunities are available in the market? You can search with that. You'll come to know everything. How Hadoop is booming.
Yeah. Yeah, I did that research. I think in next 2 years, there will be about 2 million job openings in the US on big data.
And by 2018, there will be a talented analysis persons shortage in US. That is also expected.
Oh. Okay.
By the time of 2018.
Okay.
Okay. Any other questions?
So how many weeks is this course?
This
How many days?
This course would be 30 days.
30 days. Okay. Same timing every day or?
We have couple of people based on that people requirement also we will consider and we will continue the classes, regular classes. Your coordinators will be informing you about the regular classes timings, everything.
Okay.
Any other questions or we'll wind up this class? Ayla, any questions?
Can you hear me?
Yes, I can hear you.
Oh my god, okay. No, that's fine. I like the content and I'm happy with that.
Yeah. Thanks, Ayla and Alan, Bindu. Bindu, you have any questions?
Yeah. No, nothing from my side.
Yeah. Thanks, Bindu. Thanks, Ayla. Thanks,
Yeah,
Alan.
thank you.
Okay,
Yeah.
thank you. Bye-bye.
Yeah, thank you. It was a nice session.
Yeah, thank you.
Thank you.
Yeah.
Thanks. Bye-bye.
Bye.